All right, so I think we can start. So my name is Alexander Rubin. I am a principal architect at Percona, and I am a consultant, actually, working with the customers. I started at MySQL DBA in 2006 as a MySQL consultant, so I was doing basically same job for about 10 years, switching companies or acquired. So as you know, MySQL was acquired by Sun acquired by Oracle. So now I changed and switched to Percona. About 2 years ago, I started looking into the MongoDB. And MongoDB looked very interesting for me. So I learned it myself from the MySQL background. And some of the things that I learned was amazing. We never had that in MySQL for a long time. Some of the things looked weird for me. So first of all, I want to welcome you to MongoDB world. I did this route myself. And today I will talk about the MongoDB concepts, sort of introduction to MongoDB for MySQL DBAs. So what will be our agenda? So we will talk about some basic MongoDB concepts. We will talk about the storage engines in MongoDB. We'll talk about operations in MongoDB. We will talk about replication and sharding in MongoDB, and I will give an example of GIS. I played a lot with the GIS in MySQL, and then I also start playing with the GIS in MongoDB. And there will be an actual example of how you work with the GIS concepts in MongoDB. So again, this will be a very introductory talk about MongoDB. And I wanted to basically do all the slides starts with where is my replication, for example. Where is my.cnf in MongoDB? So almost every slide will be answering to this type of questions. But before we begin, I want to ask you guys, who are using MongoDB right now in production? Okay. And who are not using MySQL in production? Okay. Okay, 2 people not using MySQL in production. Okay. 3 people. So, again, we will be talking about the differences between MySQL and MongoDB. And if you know MySQL, then it will be much easier for you to get into MongoDB world, because most of the concepts are similar. So what is MongoDB anyway? So when we talk about MongoDB, we usually say, okay, this is document store. Right? This is quite different from MySQL. But now if you've been on the last 2 days talks, or you heard about MySQL 5.7.12, it's actually have a document store in it. So it actually has ability to communicate with the MySQL tables as if it's a document store. No SQL, right? So MySQL obviously is SQL level. MongoDB doesn't have that. MongoDB uses its own JSON or JavaScript, I would say, notation to get the rows or documents. JSON, again, is a basic concept, is a main concept around MongoDB. MongoDB stores the documents in a JSON format. Actually, it stores the documents in a BSON format, which is a binary, which is a little bit different, but for our purposes, it's basically JSON. And JavaScript. JavaScript is built into Mongo shell. And you can actually use JavaScript programs inside of the shell. And in MySQL, before 5.7.12, you were limited to the queries, any queries, right? In MongoDB, you can write a JavaScript program. And there is no schema. And we'll see what it means. It's also good, and it's also different from MySQL a lot. All right, so let's start. So in MySQL, we start with a select. In MongoDB, this is what we have. In MongoDB, we use this notation, and we use the dot notation to communicate with the server. So here I have connected to the Mongo shell, and this is version 3.0. And then I do this, db dot. This is what we usually do when we start working with the current databases. So think about db as current database, nothing more than that. And then we specify the collection, and collection is table. And then we specify what we want to do, find. And there's no condition. So it's select, it's basically select star. There's no condition. There's no where condition here. And I want to do a limit 1, and then I want to format it pretty. And then I get JSON back, right? That's very, very basic. I like this SQL comparison chart a lot, because then you will find all the, MongoDB constructs that are related to the SQL construct. And I use it myself a lot because I never remembered how to translate this group by, order by, limit, where condition to this. Right? So if you want to start, this is a great reference point. This is a great start point. Okay, so now, in MySQL, what we do first? We create table. In MongoDB, it's quite different. You don't have create table. And that was, I was actually amazed. I was surprised when I started learning MongoDB. There is no tables. How do you do? You just do insert. There is no, again, remember, there is no schema. So if you want to do something, then you just do db collection insert. And you put some arbitrary JSON format there. It will work. All right? So now, select. Select is just find. So on the find, in the parentheses, yeah, go ahead.
Do you have to click create the collection first, or do you just use any name and it automatically creates it for you?
Exactly. Yeah, that's a very good point. It will create the collection for you. And also that's very funny because when you do use, and then you specify your database, it will just accept anything. You don't need to do even create database. You do use, and it will auto-create this when you will create the first collection. And this is also very sometimes funny to see because sometimes people get an access to the MongoDB, even in a development server, for example, and they misspell something. When you misspell something, it will automatically create a new collection, and people didn't realize that. So you do show tables, for example, show collections, you will see all this different stuff there, which is bogus. And this is a good point, thank you. So back to MongoDB, we have this find command, which is our select statement. And inside of the find command, you specify your where condition, basically. This is where condition, nothing more. Now, so the question is, where is my SQL? This is a SQL in MongoDB terms. Now, I usually like to start with this. Where is my configuration file, right? And MongoDB has a very similar concept. There is a MongoDB conf. If you look at that, this is different format. This is not how this is not the format that we use for MySQL. Also, what is different is that MongoDB has much less knobs, much less configuration variables. You just start MongoDB, and in many cases, it will good enough. Now, that changed actually a lot with the different storage engines, and we will talk about that later. But the concept is that MongoDB is sort of auto-configuring itself. Unlike InnoDB, where you need to specify the buffer pool size, you need to specify the log file size. In MongoDB, in the Wired Tiger storage engine, for example, then I will use half of the RAM for its buffer, which is very similar. Actually, in the latest version, it's 60% of the RAM. So it's very similar to other databases. All right, so now, this is another question that I usually ask if I learn a new technology. Where is my storage? Where is my databases? So in MySQL, you do show databases, use, and then show tables. In MongoDB, you do show DBS. And then it's interesting that you can also see the sizing on every database here. So MySQL database, MongoDB database. MySQL use, MongoDB use, same thing. MySQL show tables, you have show collections, but it's interesting that show tables works also. So sometimes when especially when I started working with MongoDB shell, I start typing MySQL commands because it's muscle memory. I start doing something. I even have hard time to type Mongo. I typed MySQL because of the muscle memory. But inside of the Mongo shell, I tend to type like show tables. And it worked. So if you are used to the MySQL commands, some of them will work here. Now, where is my InnoDB? In the MongoDB, the concept nowadays, starting with version 3.0, is very similar. There is a different storage engines available. So this is what I have outlined with sort of lines between. MongoDB, old MongoDB, starting with a version 2, only had the memory mapped storage engine called mmap v1. In memory mapped storage engine is like MyISAM. It's actually worse than MyISAM. Because what it does is it uses a memory mapped. So it loads all the data and it offloads its work to the file system. The file system now manages it. If it needs memory, it will allocate it. If it's too much, if the size on disk is larger than the amount of memory, it will swap something. So the performance of that is not what you would expect from the performance. Another problem with the memory mapped storage engine was the locking. So everyone still remembers MyISAM, right? So MyISAM had a problem and has a problem, still has a problem with table level locking. In MongoDB, it's even worse. With the version 2, it was a global lock. So can you imagine that you're writing to MyISAM table and the whole instance is locked? So there is no parallelism. That was version 2.0. In later versions, they've been introduced the collection level lock. First of all, it was a database level lock. Then it was a collection level lock. But now collection level lock, like a table level lock, is not good enough. So the WiredTiger search engine, Percona FT storage engine, and RocksDB storage engines, they all have the row level locks. So that is much better. So what the WiredTiger is actually the default search engine starting with version 3. So MongoDB 3.0 has the WiredTiger as a default one. And now in Percona server for MongoDB, we'll also have a Toku MX, which is now Percona FT. This is what we have in MySQL and Percona server as well. And Mark Callahan just did a very good presentation and introduction to RocksDB. So this is also available as MyRocks in MySQL and some distributions of MySQL, and it's available as RocksDB in Percona server for MongoDB. But basically, those are two major storage engines. We have Memory Map, which is sort of MyISAM. We have a WiredTiger, which is sort of InnoDB. Any questions? All right. So let's proceed with where is concept. So where is my process list? DB current op will give you the process list information. There are much more metrics in this, significantly more metrics than in MySQL. In Percona server, we have this rows sent, rows examined, but then here you have all the logs, like a global log acquired, database level log acquired, collection level log acquired, waiting for log. So this is actually significantly better than, I would say, than MySQL process list. Now, where's my grants? The grants are quite different. The access level is quite different in MongoDB compared to MySQL. And also, the bad thing about the MongoDB access level control is that it has been changed a lot since version 2 to version 3.2. Here, I give an example of how you add a user in version 3. In version 3, MongoDB introduced the roles. So the roles is what you allow to do and on what collection or what database you allow to do it. This is similar to our grant command in MySQL, where you say, here I do star.star. Right, but if I want to do a more granularity, I can do database.star. Here I express it as a roles. So I do read-write. So it's basically grant, inserts, update, select, delete, and then I specify the collection. Now, that is also very cumbersome, I would say. The users are per database. So before adding a user, it's a good practice to do use. So if you want to have the user for this particular collection, you do use and then you create user. But where it's actually stored, it's been changed. In version 3, it's stored in an admin database. So you need to authenticate against the admin database. There are lots of small issues with this. Another interesting thing and another difference between MySQL user model and MongoDB user model is that, first of all, you create your user admin. This is what we don't use in MySQL. We have root, right? We have root, and the root can create the users. In MongoDB, when you create your first user, it's a user admin. Now, user admin is not root. User admin will allow you to create a new users, but you cannot use user admin as root. So basically what MongoDB recommends is that you start MongoDB, you create your user admin, then using the user admin, you create a root user and your other application users. Another thing is that in MySQL, we used to specify the host name that is coming. That is much harder to do in MongoDB. Now, where's my index? In MySQL, we can do show keys. In MongoDB, because there is no schema, you cannot do show create table, for example, like we do in MySQL. So if you need to get a list of indexes, you can do .get indexes. And this is our indexes here. We have a primary key here on ID, and we have, it's actually just it. Just the primary key. Now, how do you create an index? In MySQL, we do alter table, add key, or we do create index. In MongoDB, we use this db create index. Now, you probably have already noticed that the indexes can be sorted. So if you specify right after the field name, you specify either 1 or -1. So if you specify 1, it will be similar to what MySQL is using. It will be sorting in ascending order. But in MongoDB, you can also sort in other direction. You can sort in other direction for every index, or you can also create a combined index and sort it differently. That can be actually very helpful, and this is what's missing in MySQL. You can then satisfy the order by condition much better, much faster. Because if the index is sorted, first field in the index is sorted in ascending order, the second field in the index is sorted in descending order, then you can do something like order by ask, desk, right? Ascending, descending, and there will be the same way as the index is being sorted. It was sorted on disk. So that is very interesting, I would say, concept. Now, where's my explain? It's also straightforward. You add an explain to the find command. So when you do that, it will show you all the information about the query execution plan. Also very helpful. And you look at this, you see this direction is forward. That will refer to our sort order of the index. Now, where's my alter table? Do you guys have any idea what's alter table in MongoDB? Exactly. There's no alter table. This is the example that I had to do. This is what I had to do when I was working with a Wikistats. Wikistats is a database that you can download. It's information about how many requests has been done for the specific Wikipedia pages. So you can do some like trending analysis or something like that. So I downloaded the Wikistat. I loaded it into InnoDB. I realized there is a URL here. I realized that the grouping by URL is very bad. It's very slow. You're basically grouping by the large strings. So I was saying, okay, I can convert it to MD5 on hex, and instead of storing this huge, it can be 1,000 bytes. Some URLs contains the URI, right? It can be 1,000 bytes. Instead of doing that, I can always have 16 bytes. And then, so Okay, I do all the table, add MD5 column, var binary. Took 37 minutes for me. I do update and do unhex. Took 42 minutes for me, right? In MongoDB, I could have just changed my collection and start writing the, MD5 right away. Then I can start backfilling it. And the new rows, think about production, right? The new rows will go with a new attribute, with the MD5 attribute. The old documents will have no MD5 attributes. And then I can slowly backfill if I need to. Also, if we think about that, this is architectural change. This is architectural difference in MongoDB. Because there is no schema, that's very beneficial for things like Internet of Things. Let's say we have I/O Internet of Things device, which is sending temperature. And then I updated the firmware, I updated the software to add humidity. In MySQL, I would have to do alter table, add humidity column. In MongoDB, I can just insert the new schema, the new humidity attribute to the existing collection, and nothing will change. So, yeah, go ahead.
One of them, what happened with the old collection?
What happened with the old collection? What will happen?
You added the humidity.
Right.
Created a new collection.
Right. No. This is so. The question is, if I create a new collection, I'm not creating a new collection. That's the whole concept of MongoDB. You will have a different attributes in the same collection. So in JSON is flexible. In before, I will have just temperature attribute in the same collection. When I need to have humidity, I start inserting the humidity attribute alongside with the temperature, and it will work. So then the question is, what will happen when the application will select, right? Will do that. It will get null for the humidity when it's absent, and then the application will react to that. So. But at least operationally, go ahead.
So all the old information will stay there without.
Correct. Yeah, we don't have to change the old information to add.
A little bit different than update because update.
Right, exactly. So we are talking about this part. We're not talking about the update. All right. So now, where is my slow query log? In MySQL, we do this. We do long query time. We do slow query log. In MongoDB, we set the profiling level. It's basically very similar to placing the slow query log in a table. When you specify your profiling level, you specify level 1 for profiling slow operations, and then you specify the slow MS, which is basically the long query time. And then if you want to retrieve your slow queries, then you do the normal find command, db system profile find, and you can also filter by milliseconds. Now, this is good, but what about the PT Query Digest, for example? There is an excellent set of tools, open source tools, called mTools. So the mTools will allow you to do things similar to PT Query Digest, but even better. You can do mlog filter to filter by different operations, by different parameters, but you can also do a visualization. You can do mlog viz. It will generate the HTML file based on the JavaScript library interactive. This is actually an interactive HTML page offline. When you've done that, you can basically click here and sort by the order by the nscanned or namespace or filter out some of those operations. There is definitely something wrong happening on this graph, right? There's maybe some cron job which is doing some command, some admin command, and we don't know yet. But then if we will have this graph, we will be able to drill down to this and see what's actually happening in this. So if you have, and this is not based on the slow query log. It's not based on the profile. It's based on the error log, basically. In MongoDB, the slow operations are also recorded into the error log, the MongoDB log. So you can collect that from the server, run the mlog filter or mlog viz, and get much more visibility. All right, so the next topic is, where's my replication? I think that I love MongoDB implementation of the replication. In MySQL, we had so many issues with master-slave replication and failover and stuff like that. MongoDB just implemented what we dreamed of in MySQL. Asynchronous, fully automatic failover replication based on the connector. So what you do is you just deploy the replica set. In MongoDB, it's called replica set with primary and secondary. Primary is master, secondary is slave. You deploy 3 members of the replica set, and you will get auto failover out of the box. Now, why it is so easy in MongoDB and why it's so hard in MySQL? Because of multiple things. First of all, in MongoDB, people never talk about transactions and consistency because there's no transaction and there's eventual consistency in MongoDB. So if we fail over from the master to the slave, that will probably be okay. Again, and there's no SQL, so there's no problem with the parsing the SQL statement and determine if it's safe to run it on the master, if it's safe to run it on the slave. Do we have insert select or do we have just select? There's nothing like that. The commands are straightforward. In commands, there's no transaction, there is no joins in MongoDB again. So the replication implementation is much easier to do. But it's great. You deploy the MongoDB replication and you configure it on the connector level, and it will provide you with automatic failover. Yeah, go ahead.
This is a multi-master replication or master-slave? I can write it from all servers or?
No, this is very similar to this picture. Basically, this is sort of implementation of MHA in MongoDB world. So there's you cannot write to the secondary. You can only write to the primary. But if you want to switch over, it's very similar to GTID-based MySQL replication. You do RS step down, and then you switch over. Or if the primary will go down, there will be an election. And when the election happening, another node will be elected to be a primary. Now, David Murphy will be doing another presentation where he will explain those in much more detail, the replication and sharding. Yes, go ahead.
Is there anything that guarantees that the primary and secondaries are in sync?
Yes, this is This is a very good question. The question was, is there any guarantee that the primary and secondary are in sync? This is asynchronous replication. There is, basically the short answer is there is no guarantee. The long answer, and I think that David will explain it in much more details and explain how it works and how we can make it much better. There is one thing that I want to mention is that when people start working with a replica set and they want to read something from the secondary, by default, it's not allowed. You need to specifically tell it that you are aware that you're reading from the slave. So basically, before reading from the slave, you need to say RC slave OK. So it's basically up to you, up to application, to know that we are now reading from the slave, and slave may have a delay. And there are all sorts of commands similar to MySQL show slave status that will show you the delay and any issues or any ping and stuff like that. Yes, go ahead.
The reads and writes are basically through primary, and secondaries are pretty much false.
Right, exactly. So all the writes will go to the primary, and the slaves, like in MySQL, the secondaries are connected to the primary and receives the new events. Any other questions? Replication? Okay, so now, where is my sharding? In MySQL, there are so many different solutions, and there's no full solution out of the box. There are custom solution. There's a MySQL Fabric project. There's MySQL open source. There's some other lots of open source and closed source solutions that will provide you with a sharding. In MongoDB, the sharding is out of the box, which is really great again. Now, I also asked this question to myself and to when I was learning MongoDB. I was start thinking why this is so good here and why it's so hard here. And again, the answer is architecture of MongoDB. To implement the sharding in MySQL, what do we need to do? We need to parse any single SQL query to determine where does it go. And this SQL query may be having a subquery, may have a join, may have a different, even databases, even joining a different databases. So it's a hard task by itself. In MongoDB, there's nothing like that. You either insert into the collection, you are updating the collection, or you selecting, or you find something in the collection. So sharding is out of the box in MongoDB and relatively easy to deploy. Again, David will talk about sharding today and show you all the architectures and all the details, additional details of how to deploy sharding in MongoDB. The quick overview is this. Sharding is based on the router. We call it MongoS. And those routers can be placed into the app servers. Now, how does it know which shard to go? That's why we use MongoDB uses config servers. Config servers is where it stores the information about the chunks and the corresponding MongoDB servers. Now, what is chunk? When you create a sharded collection, it will be automatically split the sharded collection into chunks based on the so-called sharding key. By default, when you deploy all this and you create a database, you create a collection, it will not be sharded. It will be only on one shard. So you specifically need to tell it, shard this collection, and use this key as a sharding key. Gavin, David will talk a lot about probably will talk a lot about choosing a correct sharding key and increasing the performance. So now going back to the router will connect for every request, for every application request. The router will connect to the config server, will find out where to go based on the information about the chunks, and route the request to, route the request to one of the shards. Now, what if our query will not be able to take advantage of the sharding key? What will happen then? Then it will have to scan all the shards. So in MongoDB, it's called scatter gather. So with the scatter gather, that means I will have to search all shards, send the information back to the router, and do some post-processing on that. So that's why choosing a right sharding key is very important. If you ever worked with MySQL and DB cluster, this is a little bit similar to implementation of MongoDB, is similar to MySQL and DB cluster. All right, any questions? Yeah, go ahead.
Yeah, so how many minimum servers do you need for the sharding?
Right, so the question is how much nodes do you need for the sharding, minimum? So you can start with just one shard. So what one shard is? One shard is usually in production, the recommendation is replica set. So this guy is a replica set of 3 nodes. So 3 nodes for the shard. Plus, we need 3 config servers. In the latest version of MongoDB, config servers is actually also a replica set. So 3 config servers for redundancy. If you think about it, config servers is one of the most important part of this setup. If you lose your config servers, then all those chunks will be a sort of mess. You don't know where to go. You have your data, but you have no ability to do anything with it. So 3 plus router. At least 2 routers is recommended. And then you don't have to actually start with multiple shards. You can start, if you start and you know for sure that your collection, your database will be very large, like terabytes, for example. You can start deploying the sharding with 1 shard. When your database will grow, you can add more shards. And then you will do so-called rebalancing. Rebalancing is spreading the data across multiple shards. All right, any other questions? Yes, go ahead.
So what about reorganizing the data between the shards after adding new shards?
Right, exactly. This is what rebalancing is. So the question was what about reorganizing the data across? So that's what we call rebalancing in MongoDB. So MongoDB is, by default, it's doing automatic rebalancing, or you can do it manually. So you can actually say, I want to rebalance this collection across multiple shards, and then it will start moving the blocks. So what does it mean to move the block? It will need to physically move it here to here, but also it needs to update our meta information. That's where the config servers are for. That make sense? Yes?
So what about the performance of the application at that time? Will it be blocked?
Yes, this is a very good question. So the question is, will the application will be blocked during this time? So that's why it's doing it by chunks. It's not doing everything at once. It will do it by chunks. And there are some configuration variables that you can use to minimize that. And also, it changed between versions.
let's say if you rebalance by doing tag sharding, MongoDB will automatically spread the chunks over the tags. And
Right. So you're right. It optimizes this process, so it will make it very low impacting on the application. All right. Any other questions? So I think we are running low on time. What I wanted to go through here really quickly is to demonstrate the one example of MongoDB. Yes, go ahead.
Yes, hi.
Yes, hey.
About backing up,
The
backup strategy for the shard.
right. This is also a very good question, and this is, I would say, I was thinking about that when I was preparing this presentation, and it's a bigger topic by itself. Backing up shards is. I think David will talk about that in his talk, but the one of the original issues with backing up everything with a sharded setup was the config servers, because before version 3.2, I believe, the config servers were using its own format. So basically, what you have to do is you do the the backup of your shards. Then you also need to have a backup of your config servers, and you need to make it consistent. If you do a backup of just one MongoDB instance, then you can also use a so-called oplog. So oplog, we didn't talk about that, but oplog is basically a binary log. And in MySQL, if you think about that, you do MySQL dump single transaction. In MongoDB, you can do MongoDump. And also, you can specify reading the oplog. So you will have the information about the oplog in your MongoDump. But again, the backup is a topic by itself. So unfortunately, I don't have much time going into that. I think we will skip this MongoGIS because we're running out of time. So let's go. Any other questions? Yes.
will you be uploading the presentation?
Yeah, already sent it. All right, I think, yes, thank you very much. Thank you.